Okay, so moving on, after we've done classes and the main method, let's now look at what we call data types and operations. So data types that Java works with, and then some of the things we call operators. So, okay, so we have what we call primitive data types. There are others, but we're going to just restrict ourselves to primitive data types. And then we start with what we call a variable. So when we come across the word variable in computing or in programming, we just need to understand that it is something that's an English word. So if we say something is variable or something varies, it means it changes. So there are so many things in our, yeah. See? Oh, okay. Okay. All right. So there are certain things that we encounter that we say are variable. And so things like as a human being, your age changes with years, your height perhaps changes, your school, your location, and all those things, your salary, the amount you earn. Of course, if you're going to earn a salary that the same salary for the rest of your life, that would not be fair. So all those things we call variables. But there are other things that are constant. They never change. And so occasionally we also be coming across certain things that we say are constant. Of course, in maths, we already know things like pi is a constant. It never changes. The same thing for a human being, your date of birth is constant. There's no way you can change. You can change it on paper. Okay, that's fine. But the date you were born is the date you were born. There's nothing you can do about it. Your parents, your mother, your father, they are constant. There's nothing you can do. And so there are certain things that are constant and there are others that are variable. We mostly work with variables. And when we talk about variable in programming, particularly in Java, we are talking about a space in the memory that the computer is going to reserve and is going to use that to store data. The way computers work, you have your hard disk, that is the permanent storage, and you have your memory, which is the temporary, and that is where the working takes place. So if you are doing once you start your computer and you are running, it moves the data or the information from your hard drive to the memory. So when you are typing, and that's why sometimes when you type things and you don't go ahead to save, and your computer goes off, then you lose all what you have typed because you have not actually saved it. It is just in your memory. So when it's displaying and you are typing and seeing something on the screen, that is the memory that is working. It's only when you are done, then you can save it. And in that case, it's permanent storage. So the memory, so what the computer does that it just creates a space in your memory and then it uh, puts information or data into that space. So when we use a variable, we're actually referring to, or we're actually asking the computer to create or reserve some space in memory so that we can put a figure or something inside. And that thing we're going to put inside is going to vary or is going to change with time. So if it's your bank account, for example, your bank account is saved as your account name. So the account name can be the variable. And then the figure inside, 100 CDs or 200 CDs, and all the time you are doing transactions is changing. When you go and add money, of course, it changes. But the variable itself doesn't change. That's the memory location that has been named bank account. It remains bank account. But what is inside can change. So when we talk of variable, we are not referring to what is actually in the space that has been allocated, but we're actually talking of the space itself or the name of the space itself. So a variable, so if I can just demonstrate something, we'll come to talk of declaration shortly. But if you put, if I ask the computer, okay, reserve some space in memory like this, and then put assuming that is my bank account, put inside 23 CDs, So here, it will give it a name. I can call it coffee, or yeah, I can call it coffee. So this is, so the variable actually is coffee. It's not the 23. The 23 can change. So if I go and take 10 CDs, what the system will do, oh, this does not allow me to do that. Okay. What the system will do is that it will subtract the 10 CDs and it will be left with 13 CDs. So 13 CDs will now be in the variable. But the variable coffee or the name coffee remains constant. So it doesn't change. The name itself doesn't change. But we still call it a variable because the information that is holding is going to be variable. So your bank account is a variable, even though the word bank account will not change. Whatever information it's holding will be changing with the time as and when you do your transactions. So when we come to Java, we have what we call 8 types of data. So we have data types, and so these, so let me move on to my, it looks like the thing has frozen. Yeah, we call them primitive data types because they are very simple, not complicated. The computer can work with other very complex data types. We're not going to talk about those now. We call those the reference variables. We're not going to talk about that. We're going to talk about the primitive ones. And there are 8 of them. So if you are working in Java, you are going to come across 8 types of data. So when we say a data type, we are only looking at what type of data can it save. So if you're asking a computer to reserve memory for you to save something, what type of data is it? Assuming that somebody is running maybe a hostel, you know, and now you are a hostel for everything, not only human beings or not only students, and you are going to ask the person to reserve a room. Now, if you say reserve a room for what? So are you reserving it for students? Are you reserving it for goods? Are you reserving it for cows? So whatever type you are reserving it as is the data type. So know that if I'm going to reserve a room for maybe 2 students, that room is going to be different from if I'm going to reserve the room for 2 cows or 2 elephants. Let's say 2 elephants. So if I say reserve the room for 2 elephants, it's going to be different. Reserve the room for 2 students, it's also going to be different. So these are in Java we call the data types. And so Java has 8 type of them. So whilst maybe in our normal house we'll have types of things that will live in the room, Java also has what we call data types. And there are 8 of them. We are going to look at the them one by one. There's bytes, there's short, there's int for integer, there's long, floats, double, char for character, and then Boolean. So these are the, in fact, once you are doing Java, ultimately you get to know all these things offhand, even though we don't use most of them all the time. So then there are ones we call the integer types. So the first 4 are what we call integer types. And an integer is just a number. So any number that you want to store, we can use any of these: byte, short, integer, or long. So we call this an integer in programming here is a number that doesn't have decimal points. No, it's not 2.5, or no, that's not an integer. An integer is 6, 10, 52. Those are integers. And so you realize that already what I was saying is that, if you say bytes, so if you ask the computer to reserve memory and you use the word byte, you cannot ask it to reserve the space for a number like 3.7. No, so if you say reserve a student room, no, you cannot bring an elephant in there because the computer has already reserved the room for an integer, and it can only take an integer. And so this we call the integer types. And then there's the other 2, which we call the floating point types. So these are the ones that take decimal points. So if you have 2.5 or 3.8, then the computer can store it if you ask it to reserve the space as float or as double. If you ask it to reserve it as integer, and you try to put 2.5, what it will do is that it will ignore the 0.5 and just put only the 2. And so we have integer types and floating point types. And these are what we call numeric data types because they are numbers. So numeric data type are ones that are, let me see, there's some feedback I'm getting from, yeah, okay. So numeric data types are the ones that deal with numbers. And in fact, most computing things that we do most of the times, we are dealing with numbers. And then we have the car, which is a character. A character is just one character on the keyboard that we type, either A or 6, or no, just one character, not 10. 10 is two characters. Mostly it's the alphabet, the characters of the alphabet, maybe B or M, those are characters. And they have a very critical purpose in Java as well. And then there's Boolean. So the Boolean type is what we call true or false, and it's used to make decisions. So Boolean is almost all the time running anytime you are using any application. Because when you click, there's always something that will compare, and then it will return either true or false. And so Boolean is very critical, and we'll be coming across Boolean as we go along. So but the question now is, why do we need all these data types? The issue is these data types, the computer has a way of reserving the amount of space that you need. So you know how bits and bytes work. Computers work with bits. That is, the transistors are either on or off, which is 0 or 1. Now, so if you say bytes, the computer is going to reserve just 1 byte, which is 8 bits of space for your number, whatever you want to store in. And 8 bits, so when you do because it's on and off, 0, 1, if you say 8 bits, 2 to the power 8, that is what you can get. The maximum is 127 or minus 128. If you go back to the basics of how computers operate, you get to understand this one. So once you tell the computer, reserve a space as byte, you can't put 1,000 in it. You can't ask the hostel owner, I need a room for 2 students. And then before you realize you have come with 10 students, because that will not work. The room had been reserved for 2. So if you say byte, you are reserving just 8 bits of space. And then you can put in, the maximum you can put in is 127. If you put 128 or 130, you will get an error because computer didn't reserve that much space. So actually when computing started, that's how, because memory was not easy to create. It was now that we have this microprocessors and systems, so we have this memory, small card, and it is carrying, millions and millions of bits of data. It used not to be like that. In fact, even the story they have been saying is that when the Americans went to the moon, the computer that controlled all the processes that took the rockets to the moon, the memory in there is not even up to what is in the laptops that we carry these days. So the one laptop that we are carrying around has more memory than the amount of memory in the computers that were used to send a human being to the moon. So you can see that those years, memory was something really, really very difficult to get in very large amounts. But now we have smaller and more efficient and faster processors and memory. So we now have 16-bit, 32-bit, 64-bit machines and so on. Oh, okay. Thank you. Yeah. Yes. Yeah, hold on. Yes. Okay. So here, once for the computer to be able to make maximum use of space and processing what efficiency and other things, what it has done is that it has given the programmer the opportunity to decide what type of data you want to store. And so you wouldn't use double or float, and then you just store a small number in it. That one you are wasting space. But these days it doesn't really matter much because computers have become very fast and plenty space. So it's not too much of a problem. But in the older computers, if you reserved, you know, double for example, and then you were using for age, because the age of a human being cannot go beyond, even by itself, yeah, cannot go beyond 120. I don't think there's any human being living on this earth that is 120 years. And so if you use double and then you are putting only age in, then you are wasting a lot of space because you've asked the computer to reserve space, let's say for 10 elephants, and then you bring in only one tiny person. Now the space has already been reserved. It can't be used for any other thing because you asked it to allocate that space. So that space is cut off. You can't use it. And at the same time, what you have put inside is just so you're not really making efficient use of the resources. So the computer has given the programmers have written things that has given programmers or users the ability to determine what data type I should use depending on what kind of data or what kind of numbers I want to store in. And so you have the bytes, that is just 8 bits, the short, which is 16, integer, 32 bits, and then long, 64 bits. Then we have float, which is using the decimal point, which is also 32 bits, and then double, which is 64 bits. And each of them now, so once you are reserving 16 bits for storage, you can store a number up to this magnitude. So minus 32,000 all the way up to plus 32,700 and something. If you go to integer, then you see that you are in the billions, or minus 2.147 billion and so on. And now if you go to long, now we are reaching the exponential points. So this exponential here, yeah, yeah, exponential here means, yeah, Musa, where are you coming here? Hold on. Another interruption. Okay. Yes. So here we now have my microphone is okay. Yeah. We now have long, float, double, and character. So all these, like I said, we're now at the exponential. So when you see this, that is raised to the power, you know. So this minus 9.2 times 10 raised to the power 18. That's a very huge number. And when you get to double, it's a very, you can't even think of the quantity. That's just mind blowing. So you can use double and save even the amount of money in the world in it. It will still take it because it's in trillions and trillions of the number. Yeah. So character uses 16 bits, but character was the one we said you have only, so technically you can store a number in character as up to that, but in actual fact, when you use the word car or character, you are only storing just one character. And we'll come to see that eventually. Then Boolean is either true or false, like I said. So all these are what we call data types. So the data types are always what we put first when we want to declare variables, as we will see shortly, because it immediately or it instantly tells the computer that this is the type of data I want to store. So the hostel owner would have looked, the first thing you would see would be, okay, student, and then it tells you that I want to reserve a room for student. If I say elephant before whatever, and then I'm saying that depending on what I'm actually bringing. So if I say elephant, I'm bringing elephants actually, and it means once you say elephant, then it means a lot of space has to be reserved. So once the computer sees double, it means it's going to reserve that much space. If it sees bytes or short, of course, smaller space. And like I said, that makes more efficient use of spaces so that you don't allocate plenty space uh, for resources and then you are not using it. You just Sometimes if you continue that, what happens is that the computer will slow down because when it's running out of memory, what it will be doing is that it will be moving certain things from memory to the hard drive. On the hard drive, there's also a temporary storage. Now, so when you have your computer, there's a hard disk that you do your storage, and then there's the memory that is working. But if you keep opening documents or if you keep running the computer for a long time without shutting it down, what's happening is that it will start moving some information from memory to the hard disk as temporary storage, and then eventually it will slow down and then probably just crash because memory is totally full. And so to make sure that you are able to maximize the use, you allocate the resources, let me say judiciously so that you can use the computer for as long as you want. So that's what data type is all about. So before we begin writing any Java program, we always need to have the system. Without these variables and other things, computers are pretty much useless because computers are supposed to be processing data and information. And as it's processing, things are changing very rapidly. And so if we didn't have variables, then what's happening is that, of course, computers will not be efficient at all. So there's something called declaring variables or declaration of a variable. And so before you can use it, we need to declare it. So and to declare it, you have to tell the computer the name that you want to assign and then the type of data it should allocate the space for. And so the declaration always starts with, I'll go next, yeah. So the type of data, whether we're going to be using integer or byte or short or long. Now, in most cases, you'll be seeing mostly integer and double because they are the commonest that we use. But you can equally use bytes, you can use short, you can use long, and so on. And so that has to come first, the data type. And then what we call the identifier, which is the name. So what name are you assigning to the variable? You need to tell the computer that. And then there's something we call an optional assigned value because we're dealing with numbers. We talk of numeric data types now. So when you declare the variable, are you going to assign a value to it? So that is optional. You can do it when you declare a variable, or you can just declare a variable and leave it as it is. And so if you write something like this, integer, so integer is telling the computer that this is a data type I want to store. And then my age is the name I have given to the variable. This one, it depends on you. You can always use any name. Of course, you don't have to use Java keywords and other things. But sometimes it's the best approach is to use names that make sense. So if I see my age, if we were to say what integer a program, or yeah, things like that, they don't really immediately tell you what it is about. But if you say my age, the computer, of course, doesn't care what name you give to it. But you, the human being, when you read it, my age, you know that at least I'm talking about my age actually. So we don't have spaces in the names. So by convention, it's always better to also start with a lowercase, unlike classes where we start with the uppercase. So so when you say integer my age, and then for now we'll say this the equal sign as we have in arithmetic or mathematics, but in programming, that's technically not the case. But for now, let's understand it as an equal sign. And then we'll put 25 and close with a semicolon. Remember we said statements in Java end with semicolon. So when you do this, what you've actually done is that you've asked the computer to reserve some space in memory and then label it my age. So my age. So this is I don't need to change the size of the font. And then you have put 25 inside. So what we've done, we say we've initialized the variable. So we've declared it, and then we've gone ahead to initialize it. So the initialization is the putting the value or the figure in the variable. You can declare the variable without initializing it. So that's why we say it's optional. I can declare another variable here. So I'll just simply say reserve space, call it, okay, my pet. I can do it like this, and then just leave it as it is. So in this case, I will just say integer, my pet, and then end with a semicolon. So what the computer will do is that the computer will just reserve the space, label it, and then leave it empty. Later on, you can assign a value to it. But when we declare, it's like going to your bank to open an account. So when you open your account, what happens? The bank will create that variable. Let's put it that way in your name. So your name, copies account. Okay. In opening it, do you have money to put in it? Okay, you have money to put in it, fine. Then we'll put in your money. So in that case, we are initializing the variable or the account. You don't have money, okay, that's fine. Let's leave it empty. You can come at any time and put money in it. So in that case, you just simply declare the variable and then you move on. Later on, you can put something in it. And so that's what we are seeing here. If I move on to my next slide. So here, we are now saying that when we do integer my age, let me clean this so that it doesn't disrupt what we are doing. Okay. When we do this, yeah, so we said integer my age. We are saying that the equal sign. So now we are going to move away from understanding the equal sign in Java as not what we have in the arithmetic, where we say 2 plus 2 equal to 4. No. The equal sign is called the assignment operator. If you want to use equal to in Java, it's double. You have to put double equal signs. Then that becomes equal to. But if it is once the equal sign, then we call that an assignment. So this we call the assignment operator. So like remember I said data types and operators or operations. So this is the first operator we will meet, assignment operator. So what we're saying is that we have assigned the variable on the left with the value on the right. So create your variable, assign a value. And when you do that, we said you've initialized, or that is initialization of the variable. So the computer, by the time it creates the space, it already puts the value in it. Later on, that value can change. Or even if it was empty, later on, you can then assign a value to it. And that's where we have what we call assignment. So there's initialization and then there's assignment. So if you do integer my age, and then you assign, so we're not going to be saying equal to 25, no, that doesn't make sense in the programming. We're not going to say my age is equal to 25, no. We're saying that we're assigning 25 to the variable my age. So when you do this, because you are starting initial in integer, you are initializing, we say, yeah, you are initializing the variable. Now, as the program runs, at a point, my age can change, or the value in it can change to 50. In that case, you are now assigning 50 to my age. So like I said, you could have declared my age without putting the 25 and then leave it as it is. And then later on, you can assign the value to it. So there's initialization and then there's assignment. Yeah. Now you can do the opposite. You can put 50. It's not like arithmetic where 4 is equal to 2 plus 2 or 2 plus 2 equal to 4. No, it doesn't work that way. This one, the compiler sees 50 first before it goes here. And when it sees only 50, it doesn't make sense to it. So you are going to get an error. So the reverse is not possible. You just have to declare the variable type first or the data type first, put the name, put the assignment operator, and then put the value. Or you can just leave it without the assignment. And then later on, you can put a value in it. So, and the computer understands that by declaring variables, that's how it goes. So here, yeah, okay, so this is what I was just talking about. So you can decide, you can just declare the variable integer my age, and then later on, you can now assign a value 90 to it. Now notice that you are not going to put integer here again. Now if you put, so let me open IDE. Okay, I think we've seen this code already. So let me leave this as it is. Now, so if I put integer my age, now, so when you do this, the computer has reserved space in memory called my age. Now, next time you can't do this. You can't do integer my age, and then try to put something. Now, when you do this, you are declaring the variable two times. That's not acceptable, because it's like asking the person to reserve the room for you, and you reserve it two times. So reserve this room, and then you are coming to reserve another room for the same person. It doesn't make sense. So that will not work. At this point, you can just you need to take out the integer, because this is the declaration, and then this is now the assignment. So you can declare without assigning, which is optional. If you assign, then it's initialization. So if I do this, it's fine. The computer has a reserved space. It has put 60 in it, but it comes to the next line, and you are telling it, okay, put 5 in it this time, no longer 60. So, and because computer is running left to right and top to bottom, now if you are going to look into my age, it's no longer 60, but it is 5. So, and that's why we say it's variable. So it can keep changing. I can try to print this out. So let me just copy this, bring it here. And then once I've done this, I'm just saying print out the variable, my age. So realize that now what I'm doing is, let me clear this. I'm saying system out print or print ln, and I'm saying my age. So when I print this, of course, it's going to print or when I run this, it's going to run the top part. So hello and all that. Okay, this was a whole lot of error here. But now it has printed out what is in my age. And it is not 60, but it is 5. Because initially you put 60 in it, but now you come to say replace it with 5. And so now if you look into the variable, what you are going to see is 5. It is no longer going to be 60, because computer has passed this and it has come down. And when it has come down, then you are going to have this. And so we have moving down, uh, whatever you now reassign the variable is what is permanently in there until it gets to a point where there's another assignment of a different value, and then it will take it like that. So here, now you can also declare, when it comes to declaration of variables, you can declare the variables in two ways, especially if they're the same data type. So you can do integer, my age 25, and then another one, let's say your age. So here I'll indicate this. So my age, we are assigning 25. Your age, we are assigning 50. So these are two different variables. Or you can do it like this. You can do integer at once, the only once, and then my age 25, your age 50. So we are declaring the variables, two of them on the same line, rather than moving from one line to the next. So but what we are saying here is that once the computer sees the integer, all the variables that follow are supposed to be integer. And so I can even add another one, integer, our age, and so on and so on. So long as they're the same data type, you can put them all in one line. Now, if it's going to be a different data type, like double or whatever, then you have to use a separate or a different data, I mean, a different line to declare different data types. So in this case, I'll move on to the next. So here, now there's an example here. So when you see bytes, my age is 25, your age is 50. Now remember, byte can only store up to 127, like we said. So you have my age 25, that is fine. Now you can't use byte and say my age 500. No, it will not go. So because byte is only just 8 bits of space. But we have double here, which is my salary. Okay, with double, of course, you can add decimal points. No, it can be 500.50 or something. But you can put all these three, or I mean, all this in the same line. So you can put byte my age, your age, and double my salary. No, you can't do that. You will get an error because the compiler runs line by line. And once it sees this keyword bytes, it's going to treat every variable it comes across as bytes. And so you can't, at a point, put a different data type there. So we have these conventions, but in most cases, it's easier to just write them on a line. Now, writing them this way, it saves a lot of time and space. So you can just put one in data type and put the variables in there, or you can also put it line by line. There's no law or no rule that says you must do this. It's up to the person writing the program to decide. Do I want to do it line by line, or do I want to do no? Yeah. Okay. Okay. So we've come across this word again, identify. So we're saying variable names are identifiers. So if we say an identifier, it means you are giving it a name, or you're identifying the variable. And we're saying it must start with a letter. And also it cannot be Java keyword. We saw the so many keywords that Java uses. So identifiers are optional. It's up to you, the programmer, what words you are going to use. But most of the times they should be meaningful. So if I see my salary, then I know what you are talking about. But if you just say double money, money is, and then you assign some value to it. Okay, the Java doesn't care. It's acceptable. It will work with it. But you, the human being, when you come across money, then what money are you talking about? Is it rent? Is it what water bill or electricity bill? It will be better to put all those names specifically. So if I say double electricity bill or my electricity bill, then next time you see it, you know exactly what it is. But you can't say double money, or those vague terms. Sometimes we use them in teaching or examples, but that's not a best practice. So declaring variables is pretty easy. You only need to remember the data type and then the name that you will give and whether you want to assign a value or not. And then, of course, there are several kinds of variables we'll be coming across. So we have what we call fields. So within a class, so when you declare a class, public class, something, any variable you come across, we call them fields. So in this, our example here, so we had, so here, public class, my program. So we're saying that any variable will come across here, we call them fields because they are within the class. Now, if it is within a method, so variables within a method, which is a block of code, we call them local variables. Local variables in the sense that it only works within that method. So methods are things that we have within classes. So like, let me give you an example I was giving. For now, this will not make sense. So here, if I have a class called copies house, so I'll just write, so public class copies house. Within the class, we can have objects. So I can say AMA is an object, and then we also have methods. So a method is, so I can write, so if I put something like cook, okay, with this, and that is a method. So we're saying that when okay, we're saying that when you do this method and you open, of course, know that you can also open, when you do this and close, it means you're going to put some things inside the method here. And then once you do that, we call these ones the parameters. In fact, no, they will call these ones the local variables because they work within the method. And then some methods take what we call arguments or parameters. In that case, we call those ones, yeah, parameters. No, they can be a variable. So like I said, cook is a method, for example. So if I say cook and I leave it like this, the question will be cook what? So I can put something inside, or I can put rice inside. So in this case, it's going to cook rice. And then I can even add something else. Maybe I can put tray. But of course, in what programming, you can't just use the word, the number three. What's happening is that you have to have a variable and assign 3 to it. And so variables within methods are called parameters. But we'll come to discuss those ones. But those names are not very critical. It's just good to understand how they work rather than, but anything. So if I were to have a variable here, integer, no time, no, not time. Okay, let me say X. Normally, it's not the best, but see, I can do something like this. Okay, a comma here. All right. So what it means is that we are saying that this method can take arguments, and one of the arguments is a variable, and that variable we call a parameter. So variables that are in method declarations, we call them parameters. So again, we'll be coming across them when we come to talk of methods. Okay. So we're going to now see whether we can do some operations on these variables before we now see whether we can run code and understand it, how it works. So the numeric or the numbers that we have, data types that we have talked about, of course, they are of no use in the program unless we do some operations on them, unless we carry out some operations. If you just say your salary is 100 and it's sitting there, and so what? But you need to do something. If I go and add money to my account, what happens? It has to take the 100 that I have in there already, add to what I'm bringing, and then I can redeposit it in my account. And so that adding is an operation that we are carrying out on the variable. So the operators are this mathematical, or the ones we all know. So we have addition, adding 2 or 3 things as a normal plus sign. There's subtraction, multiplication. We don't use the X or the times. We use a star, to represent multiplication in programming. Division is the forward slash. Now notice that if you put double slash, then you are in trouble. That's a comment. So once the computer sees double slash, that's a comment. So one slash is division. You are dividing the one on the left by what is on the right. Modulus is what we call remainder. Again, you divide one on the left by one on the right. And then if there is a remainder, that's if it's an odd number and you are dividing by 2, for example, there's going to be a remainder. So if I divide 5 by 2, I'm going to get 2 remainder 1. So it's the remainder 1, and the remainder 1 that is the modulus, not the answer, not the division between 5 and 2. It's a very important operation in programming, and so you'll be coming across it again as we go along. So these are, of course, they don't need any explanation because they are the ones that we know all the time. So let's look at now a simple code here. Now there's no need explaining public class, demo variables, public static void, and so on. This we've already explained. So what we are saying here is that we've asked the computer take some space in memory. It should be able to save an integer, name it my age, and then assign 25 to it. So that anytime I look in my age, I'm going to get 25 until I reassign it or until I change it. Anytime I look in my age, I'm going to get 25. The same thing, another one, your age, and I put 15 in it. And then a third one, our age. Then I've done the calculation. So I said our age is my age plus your age. So what does the computer do? The computer declares the variable, creates the space, but before it ends, it sees my age plus your age being assigned to it. So it's going to do the computation or the addition and then assign the answer to our age. So when you print out our age, you're going to see the sum of the two. Yeah, if somebody's, any comment or question? Yeah, you can always raise your hand if you have a comment or a question. So let's go to the IDE and see what we have got here. Let me, I wanted to clean this. Okay. So we have 3 variables. The third one, we have not assigned a value to it. We're asking the computer to do a calculation and then put the answer in that value in that variable. So we are equally initializing the variable, only that we are not doing a direct initialization with a number, but we are asking the computer to do some calculation and give us the number. So let me go to the IDE. Do I have it here? Let me see. I don't know whether. Oh yeah, demo variables. Okay, I don't need to go through the process of creating a class and all that, so it doesn't really matter now. So here, so the let me remove this because I was demonstrating other things. Yeah. Okay, so demo variables. Then we have our main method, integer my age. I use double here, but it shouldn't be double. Another integer your age. Now I can't do this because if you look at this is 15.45, but we said integer. So it's not going to understand how it's going to work, because 15.45 doesn't go into an integer data type. And that's why you have an error there. And so I need to just make this 15. Okay. And then still integer. So, and I have result, which is another. So this is what we have put in there. So it said my age is 5, your age is this. Result is my age plus your age. And we have simply asked the system to print out results. I could have added something here. We'll come to talk about that. No. So I can say the sum of our ages is, and then there's something here. I'll do this. Okay, so if I run this, what are we seeing? We're going to see run as application. So now all these are there, but of course they don't appear here because we have not asked the system to print out anything. But at this point, we say print out this, the sum of our ages is, and then we have result there. I need to put space so that when I run this, it will put the space there. Okay, so it says the sum of our ages is 20. So what we are saying here is that it has summed this and then put the value in result. So anytime I ask it to print out results, it's going to print out what is in it. If I were to make this 45, and then I run, what we are seeing is, so here we're getting the sum of our ages is 60 because that's added my age with your age. The result that it got, it has assigned it to the result. Now we've asked the computer print out results or print out this. And then now this plus sign here has a different meaning from this plus sign. So this is between numeric variables or numeric data types. So once it sees that, it's going to add them because I have numbers. I have 2 plus 3. So when it sees that, it's going to add them. But this plus here is what we call concatenation. Concatenation is joining things in Java. So I'm joining a string. So this is a string I have created, and I'm joining it with a variable. So I need to print out the string and then end that string and then join or concatenate the variable. And so that's what you will see. So it will print out the sum of our ages is, and then concatenation. Of course, it's not going to print the plus sign. It's just concat or joining the variable in there, and that is 60. So this is a simple operator. Of course, we can now do the others. So we can have multiplication. The multiplication is the star. So if I run this, you can see we have 675 because we're multiplying 45 by 15. You can divide. So when we divide, what do we get? Let's see. Now, like I said, now the moment you put 2 lines, then you are in trouble because what's happening is that you are going to make it a comment. It doesn't make sense. So by saying divide my age by your age. So if I run this, what do I get? So division, I get what? The sum of our ages is 3. Okay, now this is not sum. I'm going to say my age divided by your age, and then we can do the modulus as well. So modulus is this one, and so what will we get when we divided them? We didn't get a remainder. No, 45 by 15 we get 3. There's no remainder. So if we use modulus, we are going to get a 0 because there's no remainder there. So in this case, ignore the sum of our ages. It's just, they're just 0. Now, if I were to make it 47, you know, so the modulus here, and I run this, we are going to have, the modulus being 2, in the sense that 47 by 15, you get 3, remainder 2. So what is remaining is what is our modulus, and that's what is printed out. And like we said, it's very useful in programming. We'll come to see it eventually. So yeah. So moving on with our, oh, I want to open a new, who is this? Okay. I'll say a call at this time. Let me cancel this. I'm not launching any. Yeah, okay. I was going to my PowerPoint. Okay, so here we can do, I've already done this, divided by, so my age divided by your age is that, and so on. And now there's what we call operator precedence. Now, so if they are all operators, multiplication, division, addition, and so on, and then you put things like this, what should be the order, or what should be the result? Because if I have 2 plus 3 times 5, I mean times 4, and then this, is it going to just go left to right, or there is any precedence? Now, so if I copy this, so let me end this, and then if I copy this and I print it out, so Control C, so bring it to my IDE. Let me just paste them. You can paste them after this. So here I have my result, 2 plus 3 times 4. Your result, then we have 2 plus 3 times 4, the same thing. But we have 1 in brackets. So here, where's quotation mark? Yeah. And I just want to print out my result is this, and your result is that. So let me print this out and we'll see. So, okay, we can leave that in there. So run as application. Okay, so we see my result is 14, your result is 20, even though they are the same, 2 plus 3 times 4. So it means it's not just going left to right. It's not just taking 2, adding 3, and multiplying by 4. No. If we were to do that, 2 plus 3 is 5 times 4, that will be 20. So if we're going to do that, this will be 20, and this is also 20. Just going from left to right. But the fact that we're having different results means that there's something called operator precedence, or one is taking priority over the other, or some are taking priority over the others. And as far as Java is concerned, the precedence is that we have, anytime we're dealing with numeric data and we're doing the operators, the first thing that is evaluated is what is in the parentheses or the brackets, then followed by the multiplication. So multiplication, and then division, and then the modulus, before we have the addition and then the subtraction. So that's the precedence. So if I put 2 plus 3 times 6 over 4 and so on and so on, it's going to go like that, step by step. It will first look at where there is. So if I were to write this, there's an example there which I will show. If I were to write 2 plus 5 times 3, or another 5 minus 8 divided by 6, okay, divided by 6, and then I put plus, 6 minus 2. No, oh, something. I wanted to do this 6 minus 2, and then I go on to plus 5 times what, 2 No, no, not equal to plus. Okay, so this is a whole, you know, uh, equation, if I'll put it that way. And so what Java will do is, first of all, is going to go through it, and then where it comes across the 6 minus 2 is the one that it will evaluate first. So it will skip all the others and then evaluate this. So this becomes 8. So it's going to be all this plus 8 plus 5 times 2. And then once, and if there were another, in fact, if there were two of them, it will do the two, okay, like this. And then when it sees, once it has done with is done with those things, then it's going to look for multiplication, division, and modulus. And these ones, it goes from left to right. Which one comes first is the one that is evaluated because they are at the same level. And so when it's done with all that, then it comes to the addition and the subtraction. So the example I have here is, let me see whether it's, yeah, okay, okay, multiplication, that's, I've already explained this. Yeah, so this is the example I have. So we have 3 plus 4. Now in your quizzes, you'll be coming across things like this. So it's basic arithmetic, but now in programming, it's being applied. So 3 plus 4 times 4 plus 5 times 4 plus 3 in parentheses minus 1. So what happens? So even though plus is at a lower level than multiplication and division, what it's doing is that because they are in the brackets or the parentheses, that's the one that is evaluated first. So the first step will be to add 4 to 3. So it will be 3 plus 4 plus times 4 plus 5 times 7, because it's now 4 plus 3 and minus 1. Now, once it does that, the next thing it checks addition is of a lower priority than multiplication. There are two multiplication uh, signs there. So, but the one that it encounters first, or the one that is to the left, is evaluated first. And then the next one will be to evaluate the one on the right. And then when it's done with all that, then the plus and the minus are at the same level. So it starts from left, so it adds this, and then it does the next one, and then the subtraction is the last one. And then you get your final answer. And so if you don't know the order of priority or the precedence, then you're most likely going to get this answer wrong. Because some people will start by adding this, they will get 7, then they'll multiply by 4, 4 times 7, 28. They will add 5, and multiply by 4, and add 3. Now, by the time you finish, your answer is totally off. So we call this operator precedence. And then it's used parentheses first, followed by multiplication, division, modulus, and finally addition and subtraction. So anytime you come across any question that has this sequence of numbers with operators in them or within them, should be able to get the final answer right. So the numeric operators, there are 2 or 3 shortcuts that we can always use. There's something called augmented assignment. So what we are doing here is, if I do this, so if I declare a variable my age, I would have declared this first, integer my age. Now I say my age is my age plus 8. It looks odd, but of course it makes a lot of sense to the computer. But what's happening is that you are asking the computer to assign something to my age. Now what's happening is that you have also used my age as one of the values to do the assignment. So the computer is going to look in this my age. It will see any value that you have assigned a value to it anyway. Even if you didn't assign a value, then it will be 0. So whatever is in here, you should add 8 to it, and then all that is going to be reassigned to my age. So it's like your bank account. So you go and you deposit money. So what happens? You already had 10 cities in it. You come to add 5. What it will do is it will how does it get the 5 to add to the 10 to add to the 5? It has to go into your account. Look, it sees 10. Okay, it adds the 5, and then it re-saves the whole thing in your account. And so when you have this, but this Java allows us to do a shortcut. So you can just put plus equal to, or not equal per se, but the assignment operator. So when you do this, it's a short for doing that, for saying my age is equal to my age plus 8. You know? And so when you see addition followed by equal sign, we call this addition assignment or augmented assignment operators. You know? So it's just a shortcut. You can write it the long way if you want, but at least once you see plus equal to, that also tells us that you can have plus minus, in which case it is uh, the opposite, that you subtract 8, and whatever is left to now save in uh, my age, or all the other operators. So you can have multiplication, and then assignment operator, and so on. So we call this augmented assignment operators. So it's just a way of quickly uh, subtracting or multiplying or dividing, and then reassigning to your variable. So we call them augmented assignment operators. One other thing we can do to numeric data, or yeah, one other operator is what we call the incremental and then the decremental. Increment is increased by 1. So, and it's a very critical strategy we use in Java, especially when you come to talk of loops. You always want to increase a variable by 1. So if you want to say go around 10 times, for example, how do you keep track that when it gets to 10, then the person should stop? You need to create a variable and maybe put 0 in it. And then you say that when it goes round once, it should increase the 0 to 1, telling everyone that the person has done 1 round. It goes second round, it increases to 2, until when you get to 10, then the person will stop because the person has done 10 rounds. And so we do incremental operators. And so we always use plus plus, so it adds 1, or minus minus, that's decremental, it takes away 1. So if you declare a variable integer, my age, and you assign 12, then you say my age plus plus, what it's going to do is that it's going to increment it by 1. And then, so here, we can do here something like this. Where? Okay. Let me just put here. I want to take out this. Okay. Your age plus plus. Now, so when we do this, now I want to print out your age. So I'll just take this out and I'll put your age. So I'm printing your age. So what will it be? Initially, I assigned 15 to it. Now I say print. Let me just put your age. Your age. Okay. Concatenate. And then you have this. So in this case, when I print this, run as, so we get, okay. So, I should have added is. Okay. So run as, okay. So you realize that the incremental operator, we assigned 15, but because we did your age plus plus, it has increased it by 1. So when we are now printing your age, it prints it as 16 and no longer 15. So we call that an incremental operator. The opposite is the decremental operator. That's minus minus. So, and they are the only two. We don't do the other operators. That we don't do what star star. No, that doesn't make sense. Of course, if you do this now, you have messed up the whole thing because that becomes a comment. So it's only plus plus and minus minus. So if I were to put minus minus here and I run this now, I'm going to get 15 minus 1. So it's going to print 14. So your age is 14. So this is operators on our numeric data, and then the Boolean that I talked about. So we are left with just the Boolean and the character. So we're done. And now you realize that for the integer types, we're only going to be working with integer and then double in most cases. It doesn't stop you from using the others, but for instruction purposes, we just use only those two. Now, so variable Boolean. So when you start, just like declaring a variable, and you start and use the word Boolean, then Java understands that you are going to have either true or false. And so, again, we can print out those variables. So if I come here, I'm just adding some things here, and I say Boolean, and then I write what's my Boolean, okay, and then I say assign false. All right. So here I can print out. So I'm copying this. Oh, I remove the whole thing. Yeah. I'm copying this and I'm pasting here. Let me clean this thing before it disrupts. Okay. And then what am I seeing? So I'm trying to change this. So I'm just printing out my Boolean. Okay. So rather than your ages, I'll just say my Boolean. So of course, it's just going to print out false. So I'm running this. So it prints out, okay, your age is that. And then it prints out. So the variable, what is in it? So it is false, it prints it out. If it is true, of course, it will print out true. Now you can't do Boolean and put a number in it. You can assign 10 to my Boolean. No, it doesn't make sense because you have asked the computer to reserve some, not space, but Boolean doesn't take that much space. No, it's just that it's something that is kept in memory and then it's either true or false. And so once you refer to it, the computer can tell you, or it can check and see whether that is true or false. So, and so Boolean too is a very critical thing in programming because we always do comparisons. Is this the same as this, or is this greater than that? And then it always turns true or false. If it is true, you do one thing. If it is false, you do the other thing. So you slot your card into your ATM machine. It will first ask the program, is the pin the same as the pin that is saved in the database? If it says true, then it will say display what the keyboard for you to punch or something. If it is false, okay, display another thing. So Booleans too are used in programming a lot for making decisions. So whether this and this are true, then you can process from that. So I don't need to print this out because it's simply declaring a Boolean that says I am older, and then another one saying you are older. So here, like we said, we normally declare variables with names that make sense. So if you see I am older, it's just a name I'm giving to the variable. But if I look at it, at least I understand what it means. And so you can see this operator here. We're going to talk about this one shortly. And we know it is greater than. So this is greater than that. So what it means is that this will be evaluated. If it is true, then I am older becomes true, or it saves true in that variable. If it is false, it will save it there. And then we are going to print it out here. But like I said, I wouldn't, you can see what it is, or you can try it out yourself. It's quite straightforward. And just printing out true or false. Yeah, okay. So the comparison operators that I just talked about, that's the last but one. So you have less than. These are again the regular ones we come across in our arithmetic. So we have less than, we have equal to, greater than. Now the equal to, now so here the equal sign in Java is the two equal signs. The one equal sign we call the assignment operator. If they are double, then it means equal to. So I can compare two things. Is this equal to that? And then I can check if it is true. Okay, do this. If it is not true, so is this less than and or equal to, greater than or equal to, and so on. And then not equal to. So not equal to is just the opposite of equal to. So I can say, okay, is my age equal to your age, or is my age not equal to your age? So, and of course, I can use less than or greater than, and so. So it's just like, again, you want to take money from your account. The value you punch in is going to be compared with what you have in your account. You type in 100, meanwhile you have only 60 cities. So the system is going to ask, is what you have typed in greater than or less than, or maybe less than or equal to? Now, in this case, now you have typed in a number that is greater than the what is in your account. And so when it does the comparison, it's going to turn false because what you type should be less than what you have in your account so that you can take some, or equal to. So it should be less than or equal to. So the system will ask, is the value you typed in less than or equal to what you have in the account? And then it will true. If it's true, then it will dispense the money for you. In that case, if it is equal to, you'll be left with zero. If it's less than, of course, you'll be left with some money. But if it is not, then it will tell you the amount in your account is less than, or the bank cannot give you that money. So, and now the other two that we mentioned are the floating point and then the double, or the float and the double. So they are the same thing except that they take different amounts of space. So float takes up to, so if you see the number here, so if you declare a variable as float, it can save, yeah, up to what we call 6 significant figures, in the sense that, if you are going to have something point, something, 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 all the way, it will end at 6. So even though you are saving this number, when you want to reproduce it, it's going to reproduce this number. So this makes it a bit less accurate than that. But both of them can save money because money is only two. So 10 pesos, 20 pesos. You don't get less, 3 decimal places for money. But there are other things you need for high accuracy. You need a lot more number of significant figures. And so in most cases, we use the double, because double can take all the way up to 9 significant figures, because it has allotted a lot more space for double than for float. So you'll be seeing anytime we're going to use something that has decimal points, then we're going to use double and not float, even though float can also take a large number of characters or figures. Okay, so the floating point is okay. All right, so we can carry out mathematical operations on the floating as well. So the double, you can add them, you can subtract, you can multiply, except the modulus, where the remainder is, because you are dividing something that has decimal points by another. You wouldn't get a value. In most cases, it's going to be something that has decimal points as well. But that doesn't work in Java. So we're saying the mathematical operators, except the modulus can be performed on the floating point data types. And so now dividing, yeah, okay. Say there's no, okay. All right. So this is just a way of, okay. So the last part is what we call type conversions. So we are going to look at things this way. If I have an integer and I add another integer, the result is going to be an integer. So if the computer has a reserved space for integer and has reserved space for another integer, if I'm adding the two, I must necessarily save the result as another integer. If it's also double, then the result has to be in a double. But sometimes there can be instances where you add an integer to a double, or you add a byte to an integer, or you subtract a float from an integer or something. Now, when that happens, what will the result be? Or what will the computer save the answer as? Because if I say a double minus an integer, now the result should be saved as what? And so the computer has what we call precedence or operator precedence. So the double is always on top in the sense that if you take, because here the precedence puts it in such a way that double is always given the highest priority. So if I subtract a double from an integer, the result is going to be a double. If I add a double to a short, the result is going to be a double. So double is always the topmost priority, followed by float. That means that if I add float to integer, the result will be float. If I add float to byte, the result will be float. And so there's this order of precedence. We'll call it operator type or operator precedence in the sense that, so what we're trying to tell, let me just demonstrate this quickly. So here, you see, if I were to put, let me clean this again, because it's disrupting our, okay. I'm now making the program complex. Okay, let me remove some of this so that it doesn't confuse people. Okay, so here, if I were to have double, okay, double my salary. So let's write it that way. And I put 12.45. So this is my salary, 12.45. And I use double because it can take a decimal point. Now, if I do that for integer, it will be an error. Now, if I come to say that I want to declare a third variable, okay, another variable, let's say integer, okay, and I say adding, remember you can give any name, adding the 2. Let me write it this way, okay, adding the 2, and then I say add your age with what my salary. It doesn't make sense, but just to demonstrate. Now, okay, if you do this, now what's going to happen is that it's telling you that there's an error. It's an error because what is happening is that this variable is integer, but you are trying to save integer, which is fine, and double, which cannot go into integer because double has precedence over integer. And so because of that, you get an error here. If you make this a double, now what happens is that the error goes out because you can save an integer with a double, and then the result will be assigned to a double. So that's why we say that double has the highest precedence over all the others. And so anytime you come across situations like that, we are going to have, and that's the precedence. So double is always at the top, followed by float, followed by long, integer, and short. We call this operator precedence. The last thing we can talk about is what we call the type casting. Now, so here, even though I have a double, I want to save it as an integer. So by default, Java will tell you that you can't do that. You must save it as double. But as a programmer, I'm saying that no, I want to save it as an integer. Even though it's double, I want to save it as an integer. So we do what we call typecasting. So we add, so here I can put an integer here, integer, and I say I'm declaring a variable called integer. I'm going to add an integer, that is your age, and I'm going to add my salary. This is double. It's not going to work because the double takes precedence. So it will advise that, or it will tell you that this will be an error. But I want to force it to save it. So I will now put here integer. Now, when I do this, we call this typecasting. So I have forced my salary to be converted to an integer. Now I can save the two in this. Okay, let's run this. So I can just say adding the two, okay. Then I concatenate, this is the variable, adding the two. Remember, Java is case sensitive. So whatever you do, you have to make sure that the spelling is exactly as it is. So now, so here, if I run this, now what am I going to get? I'm adding 15 with 12.45. So if I run this, we realize I'm going to get, adding the two, 27. Now where is the 0.45? No, integer has taken it off because I've done what we call typecasting. I've forced the double here to become an integer. Now, if I were to leave this as double, okay, so if I take this out and I leave this as double, okay, now what it means is that I'm saving an integer and a double as a double. So in that case, if I run this, I'm going to get what? Something that has the decimal place or the decimal point. So 27.45. So even though Java has the operator precedence, you can always typecast or force the program to do what you want to do and override Java's recommendations or Java's priorities. So this we call typecasting. Okay, so we are winding down on this. The character is what we talked about earlier. We say it saves a single character. So if you use a data type char or char, whatever follows should be saved as just one character. And the character is normally saved with single quotation marks. So I can have my character 9, that is correct, or your character A. This has some relevance in programming, which again we'll come to discuss eventually. Now, if you don't put the quotation marks there, then you're going to get it. You're going to get an error. And so again, if we look at this, I can just do char, my character, then I assign a there, close it, and that is acceptable. I can print out. So let me copy this. Control C, paste this, and I can just print out what what my character. Oh, my. I'm just going to put this in quotes so that okay, my character. Okay, is space concatenate my character. All right, so if I run this, what am I seeing? I'm going to see here. I said adding the two is that, and then my character is A. And so this is simply printed out character. Now, if you take out the quotation marks, I mean the single quotes, you get an error because character only saves something that will be recognized as the character. So you have to have the quotes in there. So we have character and then we have string. So the last thing is what we call a string, which is just a string of characters. We've come across strings already. So whenever you ask Java to print something and you put the double quotes around it, it is treated as a string. So names are normally stored as strings, and even things like telephone numbers. A telephone number, for example, is a number, but it's not a numeric. You don't treat it as a number. You can multiply it by 2, or maybe your post office box number is not the same as your maybe the grade you've got. If you've got 50%, I can decide to add 5 and make it 55. No, if you tell me your phone number is 025, so I can't add something to it. So phone number will be saved as a string. So we treat it as a string of characters because you can't multiply it by two or do anything. So anytime you come across double quotes in Java, that is a character. And usually it's printed out exactly as it is. We've demonstrated that already. Okay, so winding down for presentation 3, what have we covered today? So we've got 8 primitive data types, 6 are numeric, 1 is character, 1 is Boolean. 5 of them are what we call numeric, no, we have what we call numeric operators, and there are 5 of them as addition, subtraction, multiplication, division, and modulus. And then we have the operator precedence, which comes first. And we said it's always the parenthesis first, followed by multiplication, division, and modulus, and the rest. So we call that operator precedence. Then we have what we call the assignment operator, which is the equal sign. The augmented assignment operator, which is plus equal. That is simply adding, let me take some water. Yeah. And then we have the increments and the decrement operators. Then we have Boolean, true or false. Then we have 6 comparison operators, greater than, less than, less than or equal to, greater than or equal to, and so on. And then we have 2 floating point data types, float and double. And then we have what we call the numeric. Oh, my voice is, I mean, my voice is deciding to, it's tired. Okay, so, and the last one is the character and then the string data types. So this is what we've covered for the day. That's a whole lot. And then I'll upload, have I uploaded the, let me see. Okay, so this is what we have. I'll check and see whether I've uploaded the slides already. But there's a simple exercise there for you to try. So you can try this and see. So it says there's a Java program, or write a program that declares variables to represent principal, time, rate, and interest. So these are variables that you are going to declare. And then assign values to them, and then do a calculation and display something. And so the calculation is saying that we're going to so this is what we call simple interest loan. You take a loan for a particular rate, that's the rate of interest over a specific period of time, which is normally years. And so you can calculate the interest. How much will you pay? That's divided by 100. So we have principal times time times rate divided by 100. That's the interest. So it's now asking you to declare variables for principal, time, rate, and all that, and then assign some values to them. So it's like somebody has gone to borrow money. You're going to borrow 100 cedis, that's the principal. And what is the rate of interest? It's normally 10%, 20%, or so on. Then over maybe 3 years, and then you can calculate the interest. And then you print it out as this. So next week, before we start, we will go over this exercise, see how you can write, or if somebody will get it done, you can display your screen for us to see how you did it. But it's an exercise for you to try. Just put into practice what we have learned. Uh, Declaring variables, assigning values, doing computations, and then displaying some outcomes or printing out something. So next week, before we start, this is what we'll look at first. Okay, so wow, enough for the day. Can end the recording now so that